Medical devices like catheters, feeding tubes, contact lenses, dentals, and other medical implants all are susceptible to bacterial infections. But did you know, for every 30 seconds, someone in this world dies due to device-related infections? And we spend over £5 billion annually just to treat these infections. With the rise in antimicrobial resistance and numbers of superbugs, the kind of bacteria that we can't kill using our existing antibiotics, this high number of infections on our medical devices will only make things worse. Worse still, the more we use our antibiotics to treat these infections, the more we risk turning regular bugs into superbugs, and we make the superbugs even stronger. And if that wasn't bad enough, the rise in superbugs is happening at much faster rate than we could find new antibiotics to defeat them. Hence why many doctors, scientists, governments all warn us about possible antibiotics apocalypse. It's an era where we're no longer able to cure common diseases caused by bacteria using our antibiotics. In order to avoid this apocalyptic future, we need to respond now. And one way to defeat the superbugs is to reduce the number of infections on our medical devices so we use less antibiotics. In my project, I made a material that is covered with nanospikes, a very tiny spikes that can kill bacteria upon contact. I had the inspiration to make this surface from nature, where in nature, insects like cicadas and dragonflies, they have similar spikes on their wings that can kill bacteria, so it keeps their wings clean. Very clever. So I make a much sharper and denser version of these nanospikes on a material called PET. It's the same material that makes our water bottle and many of our plastic medical devices. And I test the spiky surface against the bacteria. And the results, my surface can kill up to 80% of the landed bacteria, which is very promising. We're also interested to understand how does the nanospikes kill the bacteria. Interestingly, when the bacteria land on the surface, the nanospikes grab the bacteria, reduce the overall movement of the bacteria, make the bacteria stress, and the bacteria is unable to divide properly. Now, if the trapped bacteria try to escape from the surface by twitching or wiggling, this will damage the cell wall of the bacteria, which is essentially the skin of the bacteria, and eventually the bacterial cell will burst. The dips that you see at the top of the bacterial cell here with the nanospikes is where the cell wall of the bacteria is already damaged and the inner content of the bacteria start to leak out. Ultimately, we hope to kill both regular and superbugs before they can start infect our medical devices, so we use less antibiotics. My project may not just kill 2 birds with 1 stone, but rather millions of bacteria with 1 surface. Thank you.